Isaac Newton did many great things in his lifetime. He created the basic laws of motion, created calculus, and changed the way many people view our world today. He made people really think about what they saw and gave reasons for everything.
Isaac Newton was born in Lincolnshire near Grantham on December 25th, 1642, and died at Kensington, London on March 20th, 1727. He was educated at Trinity College, Cambridge, and lived there from 1661 until 1696, during which time he produced the bulk of his work in mathematics. In 1696, he was appointed to a valuable government office and moved to London, where he resided till his death.
Isaac's most memorable creations were the laws of motion, the discovery of gravity, and calculus. Without calculus, our world would be very different. We wouldn't be able to build as complex bridges or even build skyscrapers.
As you can see on the screen, calculus is very confusing to most people. Calculus is usually a college-level course. It is very complex and takes years to master.
Isaac produced a lengthy book explaining his discoveries about calculus. He originally created calculus to deal with equations with constantly changing numbers. For example, an apple falling from a tree. This book covered all of his discoveries ever since the apple fell.
Newton's laws of motion deal with, well, motion. His first law of motion states that an object in motion will stay in motion unless acted upon by an unbalanced force. Likewise, an object at rest will stay at rest unless acted upon by an unbalanced force. An example of this would be rolling a ball across the sidewalk. Obviously, the ball will eventually stop moving because of friction pushing the ball.
In this image, we see a train moving along a track. This train overpowers the friction because of its overwhelming force. According to Newton, force equals mass times acceleration, so the train will just have to accelerate more to make sure it does not come to a complete stop due to the friction.
Newton's second law of motion states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. This is shown in the video of a man kicking a soccer ball. The force from his foot is transferred to the ball, thus propelling the ball forward.
The third law of motion says that for every action, there is an equal and opposite reaction. Forces are found in pairs. Think about the time that you sit in a chair. Your body exerts a force downward, and that chair needs to exert an equal force upward or the chair will collapse. It's an issue of symmetry. Acting forces encounter other forces in the opposite direction. There's also the example of shooting a cannonball. When the cannonball is fired through the air by the explosion, the cannon is pushed backwards. The force pushing the ball out was equal to the force pushing the cannon back, but the effect on the cannon is less noticeable because it has a much larger mass. This example is similar to the kick when a gun fires a bullet forward.
So you're probably asking yourself, what does this all mean? How is this even a turning point? Well, the answers are simple!
Without Isaac Newton's discoveries about the basic laws of motion, we would not have a clear enough understanding of the world to be safe. Cars would be more dangerous, basic transportation would not be as advanced as it is today, roller coasters would not exist, and things like product manufacturing would not be as efficient, nor would they be as advanced as they are today.
So what else did Isaac do? He created calculus, one of the most advanced and challenging mathematical courses that exists. The creation of calculus took Isaac many years, and he had some help along the way. The man of Gottfried Leibniz helped Isaac create calculus.
Calculus involves formulas that use variables that are constantly changing over time. For example, the increasing speed of a skydiver over time. Isaac was very interested in terminal velocity. This is when a falling object reaches its highest speed it possibly can when it is falling straight down. Isaac was interested in this because he felt that gravity was affected by an object's mass. He was correct.
The terminal velocity of a human body is not a constant value. It depends heavily on the profile of the falling person. As an average, about 23 seconds to reach 99% of the average human terminal velocity. Terminal velocity is around 55 meters per second, and acceleration is 9.83 meters per second. So if drag wasn't slowing the acceleration, it would be about 6 seconds, but in the real world, you approach maximum speed asymptotically.
As you can see, our world would be very different if Isaac Newton hadn't existed. He truly made our world what it is today. Without him, we wouldn't be able to do so many of the technological and mathematical things that we do today. We are forever thankful for the way Isaac Newton shaped our world to be the best it can be today.